Yeah.
Yep, everybody.
So, hi everyone, in our weekly webinar. So today we will talk about PON, passive optical networks, and all subsets of it. We have a guest speaker today, Shahir Shaban from Datwyler. Before I hand over to him, so the typical thing, those who are online already in the previous webinars, if you have questions, just post them in the Q&A, not in the chat window, and then we will try to do already written answers. If not, we can try live, and if we don't get there by the end of the webinar, we can still come back through email. So it should be 1 hour that we are live. So welcome to Shahir, and his topic, or what he will do, is he will first give some introduction, backgrounder, what is PON exactly, and then we will take over again and do the field testing and troubleshooting, how to troubleshoot it. So Shahir, you took over already. Up to you.
Yep. Thank you, Werner. And thanks to Fluke for this opportunity. So today, as Werner said, we will be talking about the basics of PON, of passive optical networks. And we will answer the question, what is a PON? A PON is a passive optical network where we deliver the service from the central point to the end user all over passive fiber network. Now, this comes with many advantages, and we will see later on the efficiency on the system, and improves on traditional networks in providing a more efficient and reliable system. Now, if we want to first have a look about the components of the system of a PON. And when I talk about PONs, I cover all PONs. So when we talk about PON, that means it's if a GPON, APON, BPON, many types of PONs are available there, or EPON, Ethernet PON. They all have the same physical structure underneath. And you need to have the same performance from the infrastructure to deliver any of these different protocols, let's say, or standards. So going back to the components of a PON network, you always have an OLT, the optical line terminal, at the central office. And then you have a passive network going through single mode fiber into a set of splitter or multiple splitters, and then into our end user ONU, optical network unit. Now, the range from the OLT to ONU can go up to 20 kilometers. And if we look at this from a service provider access network perspective, this gives him a big advantage because he does not need to have any controlled environment from the central office to a 20 kilometer radius around it, delivering reliable and secure services. Okay, now we want to see how does it operate. So now, how does it operate? How does the signal travel from the OLT to reach to the ONU? Now, the OLT, it will have multiple fiber ports. Each port will be connected to a single core, single mode fiber into a splitter. And from the splitter, we will have multiple cores, each core going to each subscriber. So for a single core from the OLT, we can serve up to 32, 64, 16, depending on the split ratio on the splitter. Also in a single core from the splitter to the ONU. Now going downstream, the OLT will broadcast the message or the packet. It will go to the splitter, and it will be broadcasted to all ONUs. So if you're for any ONU on a splitter, all ONUs will receive the same packet or data or information. However, there is a high level of coding that secures the message to be read only by one user. Now, if you see, this is also a shared channel. So if you have for GPON a 2.4 gigabits, let's say, on the main core of fiber, then this will be shared with the number of users on the splitters. The good thing that this sharing is dynamic. So if you have only one user or two users connected to the splitter, they can benefit more from the bandwidth. They will take more bandwidth. On the upstream, however, the system works in a time division multiplexing. So when the ONU receives the message from the OLT, it is assigned a time slot where it can transmit back to the OLT. And so on, it transmits in its time slot, and you see that every ONU transmits on its own time slot. Now, keep in mind that these transmissions, the downstream and upstream, are taking place at the same time because we have wave division multiplexing. So the downstream is going on a wavelength and the upstream is on another wavelength simultaneously at the same time. So this is a full duplex channel on a single core supporting each user. Now, just to give you in a brief way some facts about this PON network. So they run only on single mode fiber, and one main requirement for that is because we have wave division multiplexing. We're sending at the same time at different wavelength, downstream, upstream, and there is a dedicated wavelength for video broadcasting as well. It can cover a 20 kilometer range without any active equipment from the OLT to the end user. And this gives us big advantage on the operation cost of the system. The splitters are a passive component. They are installed between the OLT and the ONU, and they can be installed just after the OLT in the same room, or you can have them close to the user or anywhere within this 20 kilometers. So you don't have limitations where you want to place your splitters. And splitters can come in different split ratios. The split ratio will give you more higher service quality to your users. So if you have a set of users that you want to give them higher services, then you can have a smaller split ratio, 1:2 or 1:4. And if you notice, all the split ratios are 2 to the power n. The reason is every time we split into 2. So you have, it's always a cascading process when we split. We split first, then again we split the suit signals into 4, into 8, 16, 32, 64. It's an asynchronous transmission in most of the cases. Now we have PONs now that are synchronous, that they have, and this means that your download speed is, or bandwidth is different than your upstream bandwidth. This is in most of PONs, like in GPON or APON, BPON. However, now we have new PON systems that are synchronous as well. It's a shared bandwidth, as we said. So the bandwidth to a splitter is shared by all the users. We have a single core wave division multiplexing on all downstream and upstream running at the same time on a single core. And to talk a little bit about the losses. So when you split a signal, this is equivalent to a 3 dB loss. This is physics. So every time you split a signal into 2, you lose 3 dBs. However, this is the pure loss coming from physics. Of course, you have other losses in your system because your splitter is spliced to a fiber and it's connected to a connector and connected. So you have to calculate all these losses. And also you need a way to measure it and test your system. Where is my loss going? I know that my splitter is losing 3 dB, but where is the rest of the power going in my fiber channel? So you have to have the right equipment and procedure to test a GPON. And this Werner will talk about later today. Now, to go and look at the benefits of this system, why people have implemented, or why this is widely spread mostly for access network, because it's a cost-effective system. As we said, we have a lower cost per user, and it's also reflected on the operation cost mostly because you need less space to accommodate. So if you look at traditional systems, you need to have more controlled areas, while now your splitter, you can put it in an enclosure under the ground or at the building entrance facility, and you deliver your service. The service provider needs only to control their central office I mean, in control, I mean to have it temperature controlled and power maintained with UPS system and so on, while the rest of the system, the ONU, rests at the user place, and it's supplied and serviced by the user, and all your network is passive. So it's less risky and cost less per user and less in operation. It's very flexible because now in your network, you can take from any splitter and extend up to this 20 kilometer. You can take from your OLT and extend to any area. So you can easily expand your system and do changes to it. Highly available. It needs less maintenance because of the fact that it runs on passive components, and you have less system failures. And the fact that it runs on single mode fiber, it makes it ready to support higher speeds in the future. We all know that single mode supports higher wavelengths and higher bandwidth. So the more we improve in the topologies that we use on the active equipment we use with the standards that we use, you can maintain the same infrastructure to provide higher bandwidth in the future. And we have seen this during the progress of PON networks from A PON, B PON, G PON, XG PON, and many PONs coming more. Now, applications and where does this fit? Definitely it fits in access networks, and there where we have seen it a lot now, where most of the service providers over the world are moving to PON, different types of PON. Some use EPON, some goes for GPON mostly. But it's there, it serves application of fiber to the X, fiber to the home, fiber to the building, so it's fiber to the location eventually. Now, this was the main use of PONs. However, now we also see PONs in LAN, a lot of PO-LAN applications. We are seeing a lot of projects coming up, and you benefit more from this network where you have a bigger campus or a bigger area to serve, with bigger number of clients to attend to. So the bigger your facility, the more you get benefits from implementing a passive optical LAN. Okay, this was my part for today. Thank you very much. If you have questions, I will be here to answer them over the Q&A, and I will be here also till the end to answer your question. I hand it back to Werner now to tell you more about how to test these PONs. Okay.
Werner, if you can unmute, yeah. Werner, unmute, please. Werner?
Yes, I'm unmuted now. You hear me?
Yeah. Yes, we do. Please, go ahead. You can proceed.
Thanks, Shahir. Always challenging to transfer.
Thank you.
Thanks. It's good to hear once from other people, manufacturers about PON and cabling. So that's not always Fluke Networks talking about Fluke Networks. And I think it's also, Shahir, I think we see already more and more applications and implementations of this PON fiber network because of the reasons you mentioned. It's cheaper, only one fiber to go into the building and then split it. So, but I think there are some, we believe there are some challenges on the testing part. So let's go over that. Agenda, inspection cleaning, a little bit more depth maybe over the PON, loss testing, OTDR testing. Some parts we have seen in previous webinars, but it's important, inspection and cleaning. Weil has spent a whole webinar on it, but it's important. This is the first step you always have to do. Inspect your fiber to check if it's clean. If it's not clean, you should clean it and inspect it again before you connect. And yeah, we cannot repeat it enough. That is that even if it comes from the manufacturer in a bag and it says, yeah, it's coming new from the production, you cannot consider that the fiber is clean or properly for installation. You still have to inspect it before you connect it in the field. Because this is an example of a fiber that came new out of the bag, and yeah, you see there is still dirt on it. So you have to clean, but after cleaning, you still need to check again, did you do the proper cleaning? Because there is dry cleaning, wet cleaning. You can also clean on your shirt if you have, of course, that you should not do. But after the cleaning, you need to check again. So yeah, I just mentioned it. We have a full hour webinar. So if you want to see that again, we have this recorded. If you can't type it now or copy it and send the question in the Q&A or ask it by email. Yeah. So a lot of things, maybe small details, but very important to know to continue. We see in this PON networks, we see more and more APC connectors. Why is that? Well, very often or mostly to cover a longer distance, you will use single mode fiber, and single mode fiber with laser sources. Yeah, these are fiber powerful light sources. And you could maybe harm some equipment or your test equipment. That's why standard UPC connectors, the light you see will be reflected back within the fiber. But with an APC connector, you avoid that this fiber will be reflected back in the fiber because it's very strong, powerful light. So to avoid that you destroy your equipment or your test equipment, so the light is a little bit angularly reflected. It's an 8-degree angle. But we see now more and more of these connectors. And this will have an influence on what you will see on an OTDR trace or how to connect everything together. So there's a slight angle, not much, but it's important. You see that if you make connections in the field, so there is this small angle, but if you have them to connect the fiber inspection, for example, you need to have the proper connector also on that side to make the connection and show up. Here's an example of fiber inspection, and maybe it's not very clear to look at it. So you have to twist it a little bit, and there is this indicator on the connector which should be aligned with your fiber inspection head to make you see now a better lightning on looking at your fiber surface and make the right decision, or let it do automated decision to decide if it's a good pass or fail fiber connection. Also on MPO connectors, you see the different connectors for an APC connector, even on MPO cassettes. We have seen in the field from experience that you come in with one fiber, you would expect you go with one fiber to the different floors, but we see very often that installers or as per design, they go to one distribution panel and then they go with MPO cassettes to the different floors. So we see more and more MPO in PON networks at some part of it. So more and more MPO connectors being used, but again, this angular connection, which for which you need to have the right connectors then on your cameras. Here you see a picture of an UPC MPO, and this is the picture of a APC MPO. A little bit darker because the light is this 8 degrees reflection gives you a little bit less light, and also to look at the picture. So these are the small differences you should take into account. Also for an OTDR trace, those who are familiar with it. So this is a typical UPC connector. You see there clearly it's a connector, but on an APC, because of this 8 degrees angular reflection, so it's a very small reflection. And sometimes it's maybe challenging to make the difference. Is this now a splice or is this an APC connector? So here you see this is a trace from a test cord around 150 meters long. So here is the APC connector, and here is the UPC connector about 150 meters, 160 meters further. That is then the UPC connector. Small details, but becomes important when troubleshooting, when testing, that you will see different things on an OTDR trace when using UPC or APC connector. So PONs, Shahir has already explained how it works. A little reminder, let's say, there are different flavors of applications that goes over PON. They talk about EPON, GPON, gigabit PON, 10G PON, XG, the Roman 10 then, XG PON, next generation PON, next generation PON 2. We said, yeah, maybe there is another one coming in the near future. So the to be decided PON, or maybe super PON, or people talk about FTT, fiber to the home, fiber to the desk, fiber to the curb, different names. At the end, we say, well, whatever you put on that road, whatever application you put there, it doesn't really make difference for the testing. We want to make sure that the road is in a good shape. You can compare it like, hey, you buy, imagine in your dreams, you buy a nice Ferrari, can drive very fast. But if the road is with a lot of bumps and humps, like in Dubai or UAE, you cannot drive fast. So the road should be clean and clear before you can get that speed for the application to run over it. So there will be different loss budgets, distances, reflectance limits. They can be tighter based on the application for future versions, but the principle stays the same. Little repetition, what Shahir already mentioned. Yes, you have this basic PON architecture. You go from a head office downstream. There are different speeds. You split the connection into the different homes to deliver video, email, different kinds of applications. There are different kinds of splitters. The splitter goes to cell towers, to even enterprises, offices, hospitals, larger enterprises, or the hotels, or all kinds of application. And you could have for eventual issues, you could have a backup connection here from the central office. So this is the basics, just to another way of picturing it, as Shahir mentioned, different speeds. So over that same fiber, so you have your OLT to send your voice data, cable TV, whatever, streaming, Netflix, whatever you want to send over. And then you can have different speeds, or upstream and downstream over that one fiber by using different wavelengths. So there could be downstream 1490 nanometer and the 1550, while upstream use the 1310 to give some information needs to go back, like an email you have to answer that has to go back. So, but you use only one fiber by using different wavelengths. Terminology, Shahir already mentioned that, but it's good. This is, I think, for those who are in the traditional installation field. So OLT, ONT, ONU, these are the new terminology that you should start remembering in PON networks. So OLT stands for the optical line terminal, ONU or ONT, the optical network unit, and ONT then for optical network terminal. So this is a typical practical layout of a PON network. So you come into the building, and with the building you have your fiber distribution hub. Again, some new abbreviations that maybe you are not familiar with. Could be a data center with MDF, and that can go to a fiber distribution terminal to the different floors. Strange building here, looks like a sleeping room or a bedroom in a hotel, but here you have the working and office area. In Dubai we have these combinations of enterprises and hotels in one building. So, but yeah, that's the principle. So you come in through this fiber distribution, go to fiber distribution terminals into fiber concentration points, and from there you can have again different connections. I saw already questions like multimode, copper. It could be even copper, could be a wireless connection that goes then from here out to the different connections point you want to have. So the OLT goes here. There's a typical picture here. You see here the main fiber part here in this, call it a mini data center. This is a typical fiber distribution hub, where you see this fiber coming in, and then it goes to different kinds of ONTs, ONUs. As I said, could be, this is for example before telephone line connections. There could be a wireless access point built in. Could be all kinds of connections going from this ONT, ONU. So this could be under the desk to connect their computer terminals in that sleeping room or hotel room. Let's say there could be again a connection for internet with the classic historical copper connection, if you still want to use that. There could be a connection to a wireless access point. There could be still the typical telephone connection, and there could be a sensor to detect if you're in the room or not in the room, so that the cleaning can come in. Or there could be smart buildings, smart homes, all kinds of connections going into this, in this case, hotel room to make these connections. What is next important? Again, Shahir talked about splitters, 1 in 2, 1 in 4, 1 in 8, the loss, etc. So let's have again a little deeper look, because it's important from the testing side. What is a splitter? You split the light that comes in, you split it, in this case, in two different ONTs or ONUs. There is still a way going up. Now, how you have to compare it or see it, you see here a box where you see the one light goes in and it comes out on all this outputs, let's say, through the splitter. What is under the hood of such a splitter? Fiber will be split into different fibers. Not much electronics, let's say. It's called PLC here. Looks a little bit weird, but there it has to, the light has to be split in these different fibers. So how you have to see it? It's a little bit like you go in the garden. You want to spray the garden with water. So you push or put 1 liter water on one side, and you cannot make suddenly extra water. So the 1 liter water will be divided in 2, and you get half a liter on these 2 exits. So you get half liter on each port, but that means you have less water. So you will have some loss on the fiber, and as Shahir mentioned, it will be 3 dB loss for each split here. It's half. 1 times 3 dB loss. It's like half of the fiber optical power you are losing. Of course, there will be a little bit more loss because of you have the connector that you need in these splitters. So for a 1 times 2 splitter, they recommend, or given the standards, you should have about 3.5 dB of loss. So it's a little bit more than the split itself because of the connector. So again, as Shahir mentioned, 1 times 4, 6 dB normally, 2 times split, but because of the connectors, you have now 2 times more connectors, so 7 dB, 1 times 8, 10.5 dB, and 16 splitter is 14 dB loss. So as you increase the number of splits, the loss will of course increase. Here you see the loss budget as per the standard TIA 568 Annex D. So here you see the more you go in splitting, here the maximum permitted loss is 3.9. For 1 in 4 split, 7.3, 1 in 8, 10.7, and 1 in 16, 14.1 dB. That's then your maximum permitted loss in this setup if you work according to TIA 568 Annex D. Important here to understand this because you have seen you have downstream some speed, but if you start splitting, you would expect, hey, the speed will slow down. No, there is no relationship between the loss value and the available bandwidth, but there is a relationship between the number of users and the available bandwidth. So GPON offers 2.54 gig per second downstream and 1.25 upstream, but all these users can still have that available. So the number of splits will not affect the downstream speed because it's a broadcast. It broadcasts to all these ONTs, but upstream there could be something could be affected by the number of users, but then based on the algorithm technology, allocation of bandwidth, you can still obtain that speed. Sending back an email, for example, not everyone doing is that at the same time, so you can allocate slots. The downstream, if you want to look at the video, that needs to go to everyone, so that speed needs to be maintained and needs to be delivered to everyone. Yeah. So first polling question, my colleagues can pull up the first polling question. Where do you use fiber? We would like to know where do you use fiber? Is it just indoor? And OSP outside plant applications are relatively new to me. You use it only outdoor. We only use OSP all the time, outside plant all the time. We have crossover applications, sometimes indoor, sometimes outdoor, or you don't use fiber at all today. It's a fiber webinar, but you want to learn, or maybe use something different. Because you can't enter here anything. So if you answer other, then and if you are interested, you could give an answer on the Q&A session, on the Q&A window. Then we can pick it up from there. A few seconds, I think I can continue present while you can still run the poll. So testing of PON networks, why to test fiber? For those who are not on Salah's how to read a fiber test certificate, a little reminder or repetition what we saw. So yeah, when installing the fiber, you want to meet the performance you are paying for. End user is paying for it. The manufacturer, Datwyler is in the call here, so they want to give warranty for that installation. They can only give that if there is a certification report. So you test it, you certify it, and give that report to make sure that the combination of the quality, the fiber manufacturing, the connectors, and the workmanship of the installer, that all that together will give you a properly installed fiber referring to the standards. So manufacturer can give warranty, and the customer can pay or should pay. So it's not always guaranteed that, hey, you buy good fiber, you buy good connector, and you have a professional installer. Still, things can go wrong, so it does not give you a guarantee. That's why you still need to test it during the installation. This is what I mentioned. So to get paid for the job. Also, it shows by experience that if your installation is properly done, professionally done, with good headroom, then your today application and maybe your future applications can go faster. Remember the Ferrari, maybe there is another car coming in the next years. If your road is properly installed and tested, then also that new faster car can run over that same road. There will be less CRC, FCS errors. That's on more an application level where you can have maybe delays on your Oracle or whatever system you are using, that you have less retransmissions, but that's now going to more too much in detail. So be aware that if you are working on a project, if you are an end user, but installer wants to save a little dollars on that installation cost by not certifying, you should ask questions. You have to request that certification report to have a proper installation and get a warranty. So what to test, and this is as per standards, IEC 61280-4-3. So you have a single stage optical distribution network, you have multi-stage, you measure the attenuation, and you can do OTDR testing. Only in the upstream direction, we will see that, because if you go downstream, because of all the splitters, the OTDR will not really be able to see, is this a 4 splitter, 8 split, is this one fiber with different connectors, or we will come back to that on looking on the OTDR trace. Band detection and future proving. So wavelengths are what we call bound. So if you test 1310 and 1550, then all the wavelengths in the middle will pass. You see that on the graph here. So if you test on the extremes, then all the wavelengths in the middle will pass. So if you have then, you saw there are different wavelengths in use for your fiber for the PON installation, like the 1490, for example, is being used, but you only test at 1310 and 1550, which is enough to do the full fiber testing. Here you see an example, quick study, small example, where you see differences. So normally the 1310, you should have a bigger loss than the 1550. You saw that in the graph here. On the 1310, you should have a bigger loss than on the 1550. So 0.45 here, 0.3. So here 1.64 on 1310, it's bigger than 1550. So this looks normal, but you have here a single fiber link, more loss, 1310 and 1550, looks good. But you have another one here where there is a bend in the fiber. And here you see now that you can detect that or measure that if the 1550 wavelength is showing you a higher loss than the 1310. So this is a way to detect that there is a bend in the fiber. And this is, of course, bad. On an OTDR trace, it is a little bit more challenging to show where the band is, because if you would only take the one wavelength, the 1310, you see here a small dig here or a small dip 2 times, but it could be a splice, could be so it's very challenging. So here you see, remember the APC connector is very small loss here, another one here. So is there now a bend in the fiber somewhere? How can you, there is maybe a loss in the middle, but how to detect that? So you have to look at a longer wavelength to detect that band. So here you see now, if you look at the 1550, now you see that band on the OTDR trace. Again, you have to look at different wavelengths at another wavelength to see that band in the fiber. Someone said it's a little bit, again, you compare with your Ferrari, you want to take a turn, or with a tractor fully loaded with some water bottles. The tractor, if they take the band, you will see more loss with the slower tractor than with a faster car. So here you see now this band on the OTDR trace. Loss budget calculation. Well, there are 2 ways to calculate your budget. One is based on the application, or you can calculate it based on the active equipment. So you look at what are the limits on the active equipment, or you look at the setup, how long is the cable, how many connectors are there, and how many splices are there. For example, here you see loss budget calculation. There are 2 splices in place, one 8-port, one 4-port splice, and the length and some fiber in the middle. So the number of, you have to check how many connectors are there, 2 connectors front end, so they can have a loss of 0.5 dB. The impact of the connectors is in total 1 dB for the 2 connectors together. How many splitters are there? Now there are different splitters, remember, if it's a 1 to 2 split, 3 dB, 1 to 4 split. So for the 4 times 4 port, remember, 7.3. It's not only the 6 dB because you split it in 4, it's 50% loss times 2. So it's not 75% loss, it's more because of the connectors also. For a 4-port splitter, you have a 7.3 dB loss. And there is an 8-port splitter, which has a 10.7 dB loss. If you remember previous slides, as per standards or And then you have your fiber, the distance. So that's given by the manufacturer, the number of the loss per kilometer. So you have 50 meter, 100 meter, 75 meter, all these distances together times 1 dB loss per kilometer gives you 0.225 dB for this distance. All this together is 19.2 dB. That's your loss budget you have for this PON setup or installation. Remember the 19.2 because later we will have an exam at the end, so we will ask you how much the total loss was. Check with your supplier also, maybe they have some specific performance specifications that you have then to include or use for your budget calculation. Next poll question, again, we would like to know a little bit from your side, how are you testing the fiber? Are you using a light source power meter? Or are you using an optical loss test set? Are you using an OTDR? Or do you say, fiber testing, when the light comes through, it will work. So we don't really test it. People could ask, what is the difference between light source power meter and an optical loss test set? I think we will have soon. I think Weil is on the list to discuss that in a full 1 hour webinar. But in short, you can have just one light source on one side and a power meter on the other side. So you inject light, measure what's coming out. An optical loss test set that will also measure the length and will calculate your total loss in function of the length against the limit. So this is a little bit more sophisticated, let's say, can do more than just a light source and power meter test. Maybe you do both, or you see now in PON installations, you have only one fiber, so it's a little bit challenging to include that length, but you can do that through your budget calculation. Again, I think we can still run it. Only half of the people have answered so far, so I continue with presentation, but my colleagues will follow up on the poll. It should show. So how is the fiber loss measured? Well, again, maybe a little repetition of what Salah mentioned or trained us or educated us in the previous webinar about how to read a fiber test report. Very simple, you set a reference. Remember the dog you want to measure or the suitcase you want to measure. You run the test and you measure the difference. That's in very short how it works. So you set a reference, which is your 0 on your balance, and then you measure the, in the meantime I saw it was stopped, so yeah, a lot of people are using an OTDR. You can use both. We know from experience, a lot of people still use or are using an OTDR for certification also. And again, Weil will explain that in an upcoming webinar that, hey, for certification, you should use an optical loss test set or light source power meter for certification and troubleshooting OTDR. Thanks for the inputs. So to come back here, first set your reference to get your reference point, your 0 point, like you tap on a balance if you want to weight yourself to put it at 0. Then you put your fiber in the middle and you measure the optical loss from the whole system, including your test reference scores, but you have to deduct the test reference scores to get the loss, optical loss of your fiber that you want to install. Now, in principle, because you don't have two fibers to measure the length automatically, so you only can have one power source and or light source and a power meter. Now, if you have this OLTS test set from us, hopefully, the Fluke Networks, the Certified Pro, you can use it in a setup for power meter, light source power meter setup. So you have to program the remote unit as a far end source. In the setup, you can do that very easily, but then you have to generate the different specific wavelength. So I had that same experience myself. So how to do that? So here is a small button on the tester, which you have to push to set the specific wavelength, single mode or multi-mode by pushing this button, and you can then switch between multi-mode, single mode. Small thing, good to know, because we sometimes get these questions, how to change this, how to start this measurement. Also, so here you see then you have your remote unit as a light source. You have your main unit as your power meter. Now we saw now in PON setups, you have very often this APC connector, which you have to connect to your power meter. And while on the source, it's maybe UPC. So you have this hybrid cord that we call, going from a UPC to an APC. Don't worry, our tester can accept both because there is no real physical connector. So you can connect your APC connectors to your power meter, and we will measure the power loss. There is no other connectors required because there is no physical connection. We measure the light loss. Yeah. Again, here a small refresher. Is it a test reference cord or a launch fiber or a launch cord? We had recently even an internal discussion. So what we mostly say, is a test reference cord. A TRC is used for loss testing, optical loss test set or light source power meter, and it's usually 2 to 5 meters long. So if you want to see it, so it's not 100 meter long. This is a test reference cord. Yeah. This is how they look like. 2 meter, 3 meter, 5 meter. They use reference graded connectors. They have a higher quality. You cannot just use a fiber test cord from a patch cord from the field, because the loss from that connector is smaller in if you use it as a test reference. Normally an adapter or a connector in typical connection is up to 0.5 dB. For a test reference cord, it should be less than 0.2 dB. So it's a higher quality. That's why it costs a little bit more, but it's a high quality reference cord. A launch fiber, or you can call it a dead zone eliminator, and its friend, a receive fiber or tail fiber, that's used for OTDR testing. So that's a little bit longer. Here you see one. So this is could be 50, 100 meter long. So this is a little bit longer. And this is called a launch fiber or a tail fiber. I showed it. This is how they look like. Just to be clear, because sometimes there is some misunderstanding or using them through each other. How to read test results, again, small refresher. Salah talked about it last week. If you want to go deeper, go to our webinars. They are recorded now on our website. You can find them there. If you don't find, let us know. Very, very important. Yeah, most important thing, does it pass? But of course, also read the rest of your what has been tested. For example, you see here, the test limit is called 4-port and 8-port. Looks like a strange name. But you see there the 2 asterisks. That means it is a user configured, a user defined test limit. Remember, we made the calculation, we made the budget that you have. So here you see the limit. How much was it? 19 point something. So it's a little bit more here. 20.5 has been used as the limit for this setup. So it's a user configured test limit, has been given a specific name, but you see the limit here, and that should be within some acceptable levels. The loss that has been measured is for the 1310 18.34. Difference, the margin you have, the headroom you have is 2.16, which looks nice, and that gives you then for both wavelengths, we do it for both wavelengths, gives you the path. Important is also to always have a quick check at this reference level. Yeah, this is a power. This is the power for the reference. Yeah, that should be around this value, -2 dBm. This is different. This is a power measurement. This is a loss, fiber loss measurement. That's what I just said. So the alternative loss test method is measuring the absolute power, which I just mentioned. The absolute power is measured in dBm. Usually it's -28, but could be -25. What we always suggest is go check with the specifications of manufacturer. You see here, someone gives it -27, the other 28, -27, but it is in that range. And you can then measure the absolute power. So not a loss. This is very important also. Loss measurement is in dB. Power measurement is in dBm. These are two different animals, let's say, that you have to be aware of. And we saw already in the field, some people are confused, put these numbers in, and then they are measuring a loss while they're then comparing to a power mode. That's completely incorrect. Also good to know is, -27 dBm is better because it's more power than a -28 dB, although the number looks bigger. But it's less negative. This is more negative. So this is more powerful. This is more power. So this is better. Also there, it's sometimes confusing because of the negative sign and the value itself, the number itself. What is now better? So very important to see these differences. Here you see that on the power meter. So this is a power meter, dBm, absolute power measurement. We also have our simplifier power meter. Here also you see the 1550 nanometer -21.38 dBm. It's a power meter. It's not a loss measurement. Very important to keep this separated. Sometimes you see in the field PON power meters. Again, it only measures the power. It's not measuring the loss. So it requires then the OLT and the ONT to source the light. So you go in from the OLT and retransmit to the ONT, and you can measure the power. But you should measure the loss. So it's interesting to know, but so OTDR testing, tier 2 testing for troubleshooting. Maybe what I forgot to mention. So when you do your installation, you should certify it, because during installation you can connect to both sides. So you should certify it. Once the PON is installed and in work and in progress, it's more challenging to do testing, because maybe on the ONT side you can disconnect one user and do some testing there, fine. But if you go on the headquarter and disconnect there your PON, you disconnect all the users, so that's a little bit more challenging. But still, there are ways to do some troubleshooting even on a live fiber. Let's see the technique behind and the difference. So an OTDR that shows the distance on the events on a fiber can be measured, can be used to measure the loss and the reflections of events. So if there is a connector, splice, splitter, the loss testing is more accurate if it can be done in both directions, but that's mostly only possible during the installation before all the active equipment is being connected. It works better upstream for PON networks with splitters. We will see that. What is the challenge there? If you will do that downstream, you should require a launch cord and a tail cord to measure the first and the last connector. Again, Salah has mentioned that, and for sure we will repeat and refresh that several times in different webinars. And check the launch and receive cords prior to testing, setting the reference of your cords. Very important to have this in place. This is a classic OTDR trace. So here, you have a loss, but it could be from a splice or could be from an APC connector. Remember from the beginning what we showed you, hey, this 8 degrees angular, it's a smaller loss than on a UPC connector. So very, very important to know and to be aware of it, that when you see then a relative small loss, is it now from an APC connector or is it from a splice? If you zoom out a little, how the OTDR will measure that. So it will measure the level here and the level behind the event, and then measure the difference. So, and that is the loss of the event. Based on that loss and based on some other tricks, we can then decide, is this a splitter, is this a splice, is this a connector, and define it that way. So this again, relative similar loss as here. So this could be a splice or an APC connector. Then the end of the fiber, there you see a huge, larger spike. So that is the end of the fiber at about 650 meters. So here to show you what is the challenge we have on downstream testing with an OTDR. Well, if you put your OTDR and you would start testing downstream, so you send your pulse over that fiber, the splitter will split it, and there will be reflections coming back. Now, the OTDR, he thinks there is only one fiber, so all the reflections that come back from that one fiber, he cannot really see on that reflection, is this now coming from these 4 fibers from a splitter, or are there connectors, for example, on that side, or what else could it be? So is this a good 4-port splitter, or is it a bad 8-port splitter? Is this the end of one fiber, or is this maybe a connector? So the OTDR cannot really see that. That's why it's pretty challenging to do an OTDR test in the downstream way of your PON installation. So how to troubleshoot links on PON? Of course, the first question always when there is an issue and you go to the TAC or to the help desk, did you try to reboot? I did yesterday. Someone here in the family had an issue with charging the iPad. We checked the cords, everything. We changed the cord, and then when you go to the TAC support, online support of Apple, first question: did you check the power supply? Did you check the cable? So some basic testings, of course. Did you reboot the unit? You start, of course, with your management agent to check there already. Hey, what is the power you see there? Is that within the range? Is it at a specific distance? You can check there already. Here you see some examples of a PON installation under a desk. This one fiber comes in, and then you have the different, in this case, so one fiber goes in, and you see the different LAN connections then. This can be, again, copper. So from here you go then with copper to your computer, because still not too many computers have a direct fiber connection to connect to the internet. And you can then measure the power on that splitter in the field and see if that is within specifications. So troubleshooting a live network with an OTDR. I think we mentioned already, an OTDR, you shoot a pulse on the fiber, you measure the time it comes back. So an event that is far away will take more time to come back than an event which is at a short distance. So closer events come back sooner, further events take longer time. But what if the OLT is already transmitting on the fiber? Yeah, the light is always on. So if you then connect an OTDR to it, he will again not see the difference between, is this light from me, OTDR, that I transmit and now want to measure the reflections, or is it coming from an OLT or an ONT? And how to tell that difference? You can unplug the OLT and run, but as I mentioned, if you unplug the OLT, then everyone will be disconnected. You will get a lot of complaints. Or what you can do is, and that's the most common way, that is use an unused wavelength. How does that work? First, if you want to connect, it will say, hey, there is a lot of fiber, the 1310, 1550 is there, so disconnect and use a filter. So this is the setup. So you have your your OLT, it sends fiber. You have different splitters along the right, let's say. Here is a 1-to-N splitter, and you go down to the ONT, to the user. Now you want to test with your OTDR upstream. Remember, downstream testing, a little bit challenging because of all these fibers. The OTDR will not know, is this light coming from one fiber, connectors, or different fibers. So if you go measure upstream, although there is light coming from the OLT, but that is using, remember, the 1310, 1550, 1490 different wavelengths on that PON fiber. So we are going to use a 1625 light source for the OTDR, 1625 live fiber for the OTDR, and all the rest, all the other lights, we will block it by a filter. So you inject light 1625 to do your injection of the light, and you measure reflections on the 1625. All the other reflections from 1310, 1550 will be blocked before it reaches your OTDR. And in that way, you can do nice upstream testing, because then it will be only one fiber. So a 1625 live fiber filter allows OTDR to use an out-of-band 1625 test wavelength to meet this purpose. Out-of-band means out of the typical band you use for your applications, for your video streaming, your email, etc. And it will not interfere with your active power over local area network signal. The filter will then block all these active lights that comes or will then not come into the OTDR port and prevent it for entering or interfering with your OTDR trace. It's a little bit like an amusement park where, you know, there are some places that says, hey, children, or to say, hey, who can go on that ride or who cannot go. They say, okay, from a certain length, you can go in. If you are below that length, sorry, you cannot get into the ride or into the entertainment park, or that part of the entertainment park. Here's a simple trace of this 1625. This is a connector. This is a splitter, typical splitter, a trace of a splitter. And this is the reflective event at the end of the fiber. So this is a typical trace of a 1625. Giving the short distances in a typical LAN environment, PON LAN environment, and the large dead zone, you may need to use a short pulse with a very long as possible averaging time. And with only one wavelength on live fiber, you will not be able to find a bend in the fiber. Remember in the beginning, we said, hey, on 1625, the band, the loss was very small. You should use a 1550 or another shorter wavelength, but if that's not possible to use it, then it will be more challenging to see or discover that band on the fiber. So some small things you should know or keep in mind when you do this troubleshooting on a PON network. And another one that sometimes when an installer is installing this PON network and he wants to check it, test it, that he will connect the OLT almost directly with the ONT with only a 2-meter patch cord. Be aware that hey, there could be a huge difference between the transmission power and the receive power. So with a 2-meter, you are injecting too much power to that ONT and it will not work. So some people start getting worried, hey, it's not working because they connect it too close to each other. Yeah. So receiving power 8 dBm and you only can have 2.68. So in conclusion, the PON, passive optical local area network, is a valid alternative for pure copper networks because what Shahir already mentioned, is cheaper, only one fiber to pull for a pretty long distance, and then at the end you split it to the different users, so it's cheaper. We see it more and more coming, not just for to the home, let's say, from the telco to the home, because it typically comes from the telco environment. But we see now more and more that this is being applied in hospitals, in universities, hotels, government buildings, where you want to reduce a little bit cost of installation by using that one fiber, go from one building to the other, and then start within the building, start splitting to the different floors or to the different locations, different hotel rooms, etc. So we see more and more of this passive optical networks appearing. You should follow then these best practices for loss testing, the one jumper reference, calculate your proper loss budget, because now you have the splitters along the line. OTDRs can be used for troubleshooting. Of course, inspect the fiber before you connect them. So that's a little bit our conclusion on testing. What we forgot previous time, so don't forget, we have, in case you don't know, we have a fiber for all promotion running, and it's almost running out, half of June. So very quickly related to this webinar, so we have what we call our OptiFiber Pro. There are two main versions. Let's say there is the OptiFiber OTDR and there is the high dynamic range, which is then mainly for this passive optical network testing. So the Pro is more for data center environment. You have the typical trace, but what we show you this event map, so very easy to use. You have very short patch course will be recognized. We have this event map table trace view, but the event map is very easy to understand, let's say, while other devices, other brands, they use, you can only use with the trace or very complicated to work with. Mostly we start with an auto setup, but you can of course manually change settings. So we have a very powerful fiber guidance built into the equipment. You see reflectance measurements. We do the reflectance measurements on the OTDR. Ideal for campus, enterprise, industrial network. And what is a typical application? Yeah, where is the problem? What is the problem? Is it the connector? Where is it exactly? So in this case, from the unit out, 105 plus 50 plus 2 plus 50, it's around 210 meters. There the fiber is broken, or that's the end of the fiber. So the high dynamic range OTDR is more for the PON, passive optical networks, larger buildings, hotels, outside plant applications, FTTH, FTT fiber to the desk, a higher dynamic range. So when we can discover automatically this splitter. So here you see a screen where you automatically discover in this case, a 32 port splitter. With all the typical measurements and give you a pass on that fiber link. We can even detect, you see here, multiple splitters along the way, 2 4-port splitters, at what distance they are. If you consider a OTDR tester, check if others can really do that. We have the 1625 for this live fiber testing. We explained that because you need an outband wavelength to do troubleshooting while the fiber is live and active. What is included? So we have in our promo till half of June, we give up to 28% promo discount. The typical OTDR has a multi-mode, single mode included. If you have already a DSX Versif, you can just buy the module to add on, as we said, specifically for data centers, industrial, 5G installations. And you have the high dynamic range with the 1490 extra wavelength or the 1625 for live fiber testing as a module, as a standalone. You see here we give up to 38, and the add-on module, I think it's even up to 45% discount temporary, specifically for this passive optical networks and longer fiber runs. Just to let you know. And if you want to have the full bundle, there are many more items. If you want to know what is all under this fiber promo, contact your distributor. But if you want to have the full bundles, you see also bundles with copper and fiber have this discount. This is DSX 8000 Pro with all kinds of accessories. It's like if you are a little boy, like a Lego box. So everything is included in this Pro. That's really a complete set for copper and fiber testing and certification. Linkware Live standard included. We saw that last webinar from a while, how to do remote team troubleshooting, team work, and especially in these times now with social distancing. Should be physical distancing, but we still want to stay in touch. So the promo ends soon. So if you are interested, act now, contact your distributor. And then maybe before we go to the questions, still a last poll. Just we would like to know, are you using already Fluke Networks or not? Do you have a CertiFiber, an optical loss test set, or do you have an OTDR? And do you have an OTDR, or you don't work with fiber at all? So last polling question, just for us to know. It was interesting to know.
Thanks.
Still,
So
then we have our questions. Run
think
for 1 hour.
I think many questions were answered already, but yeah, we have some other interesting questions that. So a question. Yeah, so we use PON for TV installation on site. According to the info, can we do an OTDR test from the user premises to the main unit room?
Sorry, yeah, as we mentioned, that's what we call an upstream test. So that you can do even in a live fiber, you can do that. So yeah, you can do that. We see the different splitters, but you need to take into consideration if it's active. Yeah, you have to make sure that you filter the active fiber light or the fiber which is used for the transmission, that you filter that out. Otherwise, the OTDR will not know what to do with all this light that comes into the fiber.
So for new PON installation, shall we use an OLTS or OTDR for certification?
Well, typical, as per standards, you should use for certification, you need to measure the loss, physically the loss at the end. So for certification, first step is what we call tier 1. Certification is a optical loss test set or a light source power meter, yeah, to measure the physical loss that comes on the other side of the fiber. An additional test to show you even how the fiber looks like is an OTDR test. But using only an OTDR for certification, that's not as per the standards, that's not what we recommend. Of course, if the manufacturer or the consultant says, give us an OTDR report and we will then decide if it's good or not good. Yeah, that's then up to the consultant or up to the specifications for the project, but it's not what it should be. Even if you have that, we would say, come to us, let us know which consultant is telling that only an OTDR is accepted for certification, because it should not be the right way to do it.
Yeah, another question, which test method is the best to test downstream in GPON filter network? So is there anything that can be tested downstream?
Only you need to, during the installation, you need to, that's why, again, if you go back to what we said in the beginning, we test the road, and then whatever application you put on it, it should or will work if you do proper testing of the road. So the downstream testing should be done before you connect up everything, because otherwise it will be very challenging. You have to disconnect active equipment to do proper testing. Yeah, it is possible, but you will have to disconnect some users from the line. Yeah.
Another thing, in data center applications, which tester we should use? Yeah, it's a little bit not on this topic, but maybe we can answer that. Yeah.
For fiber data center, testing fiber in data centers. So yeah, if you have multi-mode and single mode, we have our OptiFiber Pro, which has multi-mode, single mode. If it's for longer distances, more in PON environments, but even that comes into the data center, yeah, you should have this high dynamic range module, which is pure single mode.
And
anything you want to add, or Weil wants to add?
Yeah, well, we got a question here, I think, to elaborate more about this question. How many filters can we cascade in the link? I think this question can be answered maybe by Shahir, if you can have any guidance from a cabling point of view. Is there any limitation on how many splitters we can cascade?
Yes, it's limited by the split ratio. So you can split up to 128 times. This could be in one splitter, that is 1 into 128, or it could be 1 into 2, then 1 into 4, and then the total will be 28 splits. So the number of splitters you use, there is no limitation, but the limitation is on the number of splits you have at the end.
There was another question, which was answered by you, but I think it's worthwhile also considering the audience. When we are doing the passive optical network installation, so we're using single mode cables. Is there any chance that we can use multi-mode cables on passive optical LANs, or is it strictly single mode? Can you elaborate?
Yes.
And what is the limitation behind that?
Yeah, it's only limited to single mode, and the reason that was discussed also in Werner's presentation, that we are using on a single fiber 3 wavelengths. One is for upstream and 2 wavelengths are for downstream. So we have a wave division multiplexing over the fiber running at the same time, and this is only possible in the single mode fiber. So from the OLT to the splitter is a single mode, and from the splitter to the ONU is also a single mode fiber.
But then after the ONU, there you could use copper wireless.
Yeah, of course, yeah.
Anything else?
Okay.
I think most of the questions were answered, and if anyone did not receive the answer, we will send it in a separate email directly to.
So then I would thank you. I forgot the slide. I thought I had a slide. So next webinar will be next week about, I think it was how is your fiber ready for future applications? That's the one, Salah, you will do? Yeah?
Yes.
So next week, Tuesday, same time. Also, if you have some feedback about timing, because last week we saw several people came a little bit late in the webinar. That's why we started now at 1:30. You know, with Ramadan, so it's a little bit trial and error now when to start, which day. If you have some recommendation or you say, hey, it's better to do it that day, then let us know by email, or we can answer now. Then we can try to take it into account, but we see a lot of people on board, so I think we found the hotspot for the webinar. Okay, then thank you everyone for joining again, and see you next week. And thanks, Shaheen, for joining us, and
Thank you
for the support.
It was a pleasure.
Just a reminder that this webinar is recorded, and tomorrow, the same time, you will receive, all of you, an email related to the recording, so you can view that at your own convenience. So if you still don't get it, or you need to share that presentation of that recording with any of your colleagues, please feel free, reach out to us, and we will be more than happy to help you. Thank you for this, and I'm stopping the recording now.